day, so then it's better. Yeah, so I hope you're okay that this gets recorded, put out on YouTube, and to share your slides, or is there any issue with that?
Right now?
No, in general. I mean, I just want to
you
ask.
mean PDF file? Yes, I will send you, but it's not very useful without demonstration, because most of things I will show with the software.
Yeah, but we usually put these videos out on YouTube. So
yes, I know.
Yeah, so then people can watch it, and you can, I mean, yeah, you can put in the
I thought
package
you
of files or something.
Presentation. So
yeah.
Okay. So
Max, you're happy to do the initial bit of PowerPoint, or how do you want to do it? I
can do it, or you. I mean, if you want to, I can.
I don't care. I really don't care, to be honest.
No, then I can do it. I mean, I've done it.
Yep. Yeah. Go for it.
The routine internalized.
Yeah. That's right.
We can take it from there. Yeah. Good. So how are you, Stefan?
Yeah, I'm good. I'm actually in Poland right now at my. We just arrived a few days ago.
All right.
At my wife's parents, and we'll be going to be here until January, I think.
Okay. So, do you think you will be allowed back? Because Australia has this sort of super tough, yes.
Yeah, they were very strict.
Requirements.
But they have opened the border. I mean, so you were actually not allowed to leave or come back, but they have changed it now. With the new variant, I don't think they're going to completely shut it, but they have put quarantine back into place for when you come back. So South Australia's got 14 days, and before it was only 7. And there's not going to be anything once we reach 90%, which we probably will by early January.
In terms of vaccinations, or 90?
Yes, 90? Yeah, we've reached 80% now, and we're heading for 90, really Australia-wide. So the vaccination rates are really good, but everyone's really concerned about the new variant, obviously, and what's going to do. So, yeah, but we're lucky. So I think if we arrive today, we would have had to quarantine for 14 days, and we've got a young son who's almost a year old now, so that would have been a nightmare.
Yeah.
So, yeah. So, but we got lucky. So all is well. We don't have it, which is great.
Yes.
How are you? How are you going?
No, it's generally fine. I mean, I'm in the home office, and Anna is sitting 2 meters from me. So yeah, it's fine. Of course, Germany is going a bit sort of through the roof right now. So I'm just waiting for restrictions to kick in. At the moment, it's still sort of in between, but I think any day something will come. And yeah, I mean, we've been lucky so far, but then, for example, Anna's parents who are in the US just got it a couple of days ago. I mean, they're vaccinated, so hopefully it won't be too bad, but they've been tested positive. So
no, wish all the best.
Yeah. Well, so far it seems nothing too serious, but
so are we still in practice session, or are we actually?
No, somebody clicked that away. I don't know. We can stop actually.
No, I'm wondering whether we're live actually.
Hello to everybody. Thanks very much to Complete EM team for this great opportunity to share my soft and some other ideas. And I congratulate all of you with the first day of the winter, of course. And now we are starting. Am I hearable? Is everything okay?
Yes, all fine.
Okay. EMP, it is a Windows-based software for the processing of frequency domain EM data. mostly magnetotelluric, radiomagnetotelluric, and control source EM. What it includes? It has some input as ASCII time series. It can be raw time series, or I mean a raw table, ASCII table, or time series by Alan Jones. It can be Phoenix, Midronix, Crystal Globe, or Vega, or Microcore, or LEMI. It will be added soon. But many different formats of binary and ASCII time series can to be as inputs for EMP. Then, sorry, I have to hide one notification. Yes. Processing data. You can load EDI files or PLT files as a transfer functions or spectra. Then you can load Z files from EMTF or mod-EM data files. For example, like response functions to compare your processed data and modeled data. And of course, you can to load some project internal binary format, but maybe it can have some issues, and I prefer to use only first one things. So when you loaded your information into the EMP, you can interactively look at, play with data, change, resample, and doing many things, and look at result immediately. Because it has, as I can judge, very useful user interface. And what can you have as output from EMP? First of all, it's of course ASCII time series and binary time series. For example, if you have some complicated input time series like a Phoenix one, you can export them to the simple table or simple binary table and process in MATLAB or in any other software. And of course, you can export your spectra and transfer functions as a process data. It can be ASCII transfer functions as a usual table, or EDI files, or Z files, or mod-EM data file, or Mari to the EM data file for inversion, Rebok, Maki, and zoned to the MT. So many formats for inversion software is also supported by EMP. But the main feature is, of course, EDI transfer functions. And then you, of course, can prepare some models for the inversion, because you can look at your data, and it's absolutely good idea to incorporate preparing the model looking at your data. It can be for mod-EM in 3D or some skeleton preparation for model for mother to be. And a couple of words about good sides of EMP. It is free. This is maybe the most good side. No matter where are you from academia or industry, it is free without any limits. And of course, you can play with your data, look at results, changing something, settings, look at results again, and it's interactively. And then one of the important features is incorporating into the same processing framework data from different receivers. But to be honest, I didn't test it well because I just don't have such data, but it has to work. And a couple of words about bad side of EMP. Now it's a black box. It's not open source because the source is just not prepared to be opened. It's like a garbage, and right now it's not open source. And of course, it's Windows only. I promised to try to make it cross-platform, but I had some issues with user interface, and maybe I will fix it a little bit later. And of course, it has bugs. A lot of bugs, but thanks to some guys, I fixing some bugs which I cannot catch myself, and it became better. Now let's go to some details about EMP. We have three main types of inputs. First of all is a single file. Secondary is a folder or directory, and a project. Single file is a good idea for example, TS format or something crystal globe formats, where you have all information about your measurements into the same single file. But if you have no, for example, like in LEMI or in Phoenix data, you have to use a directory to scan all directory with your TBL, for example, and time series data and incorporate them together. And this is some warning for you. Be careful, because the EMP will read all known data types exist in your directory, including subdirectories. If you want to avoid these things, please separate your data into the different directories. And the one important thing is project file has no information about raw time series. I mean, it has only a link to the original file in your machine, but have no time series itself, because the project it will be very, very heavy. This also be careful. Don't move your original time series files after your project is made. But of course, EMP will vary you and allow you to relink to the original time series file if something is lost. Now, how the data are structured inside the EMP is, to my mind, is very straightforward and simple. Of course, main object is the station, place in the world where you are measuring your data. Each station has one or several events. Event is, let's say, one pressing on the record button, some time series with the same and single frequency sampling. Of course, it can be several events or one event, no matter. Then for each event, you have a frequency band where you can tune, for example, your frequency bands for processing, or maybe change your sampling frequency, resample on something else. You can make some processing schema for each event. And of course, you have a specific data sets for each event, for each channel. Channel 1, channel 2, it can be many, many channels. Then for processing schema, you can make many segments for processing. For example, it can be several fragments of your time series, or just several processing settings. And different, of course, type of processing. In EMP, I have three types of processing: MT, CSEM for a narrow band processing, and RMT. All of them has some specific settings and specific processing approaches. Then, of course, for each segment, we have settings. We have some count of decimation levels if you want to make a decimation, and the filtration history to correct your spectra after filtration. Each decimation level has its self-dynamic spectrum. It's some type of object which you operate with during the processing process. And how the workflow will look like. First of all, of course, I missed the loading data is first. Then you can correct your metadata. For example, if you're mistaken in E line length or azimuth, you can fix it. Then you can go to the time domain data preview, pre-processing, and pre-weighting. Before your robust weighting in the frequency domain, you can pre-weighting in the time domain. Then you are selecting your suitable processing settings. Then when all preparation are done, you can just press one button and conveyorly process all of your loaded stations. Then, of course, you can do some pretty simple, but maybe a little bit useful data correction and analysis, and export your data to the inversion software. Couple of words about one more benefit of EMP. Is compiled code. It is one executable, actually it's two executable files. First of all, you are downloading your archive and extracting it somewhere in your hard disk. And it looks like this. One configuration file, one executable, and one library for Fourier transform, of course. Then you double click on the executable and waiting a couple of seconds, and voila, you have an EMP. It's so why I started to make the EMP. For me, it was very, very difficult to use open source academic software because it was very challenging to compile and very challenging to operate it using command line. Only because of that, I started to code myself processing to have a looking at data. So now maybe, no, I will continue here. Yes, we have a first screen is a welcome screen. I think I will go to the code directly. Loading, and here we are. We have an open area where we can do open file, open directory, open project, and do some manipulation with calibration editor. When we have an area to set paths to our calibration directories, it can be different, and many of them. For example, in my case, I have several data with different receivers, and I can put here paths to the different calibrations for specific receivers. Then I can have, I'm sorry, please give me 1 second. I'm back. So one more thing. Here you have a button to translate your user interface, for example, for Russian language if you want, or going back to English. Then let's come back to the presentation. Boom, 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 boom. We have no memory. Yes. Then you can correct your attributes or metadata. For example, let me come back once again to the code and open one of the file. For example, time series file. Here is your map. For example, you can change your provider here to something loadable. Maybe it's no information about map here. So first of all, you can see the stations. It's only one station, and because of that, you can see this timeline without any other stations. So here you can change your type of channel, your ID, for example, to see the correct calibrations, the gain, the length of the line, azimuth, and maybe if you want, you can reverse the channel if you forget to put it correctly, for example. Then you can make some latitude and longitude correction and so on. What I have to say about azimuths. One important remark about azimuths. If you are loading your raw data, it's labeled here that it's raw time series. EMP assumes that your azimuths are magnetic. For example, if you're loading EDI file accordingly to the file documentation, it have to be true north azimuth. But for example, if you have true north azimuth in raw data, you can to correct your declination, set here 0 and apply. What else? Yes, of course, you have to have correct IDs to look at calibrations, because of course it's switchable for particular device. Then let me please, yes, this is a tab here in the corner where you can to come back to your welcome screen. For example, here I will open some EDI files without coordinates and show you how can you correct coordinates in the EMP. Here are stations, EDI stations. You can to press here a bit and maybe manually correct coordinates or open one text file looking like this. Name, it has the same for name here. Latitude, longitude in VGS 84, of course. And then open it, and voila, we have a map. Let me please go away. How to, okay. Maybe, okay, this is a map. And then we are closing it and coming back to our processing screen. Here we have some data coordinate system. What does it mean? Let's press update and look at what is it. It's of course X and Y axis, no special. We can to correct azimuth of the X axis. We can to move the origin, for example, here or here. We can reverse the Y axis or fix it. And of course, it's necessary for your model building and for export your data into the inversion software. So here you can tune your data coordinate system. And usually the azimuth takes from the azimuth of your stations. What else? I think that's it about your map. And of course, let me please come back to one time series, raw time series. And of course, make it a little bit wider. Yes, one more important thing is if your time is wrong for starting of your record, you can change it here. For each event, you can change the start of recording for each event, selecting the year, selecting the month, and so on. Then let's go to the time series tab. It looks a little bit ugly, but it's not the point right now. So here in the right hand side, you can see the settings tab with several settings. You can see the tool tab is specific for each tab, for calibration, for transfer functions, spectra, and so on. And now we will discuss a little bit about the tools for each specific tab. For example, in the time series, first of all, using mouse and scrolling, you can scroll into your data, for example, like this, or scrolling on the one axis, or moving your wheel to zoom here, to zoom here. And what else? Yes, this is bands of your processing segment time bands. For example, if you will move it, you can see that it moves also here for processing schema. And we can, for example, trim some bad areas of time series and process it independently. Here we can do remove mean if you want. If you have a segmented time series, you can to switch the borders of segments to look at, but here is continuously, and switch between units of your time series if you have some information about conversion from ADC quantities to the volts. Then here you can estimate your quality in time domain. For example, if we specified our window here, we can to press estimate quality and look at here's a rating from 0 to 1 as a weight. And for example, the outliers are down-weighted successfully. For example, you can hear the count of your realizations here, percentage of discarded data, and some rating from 0 to 5. And now it's more or less not good or not bad. Then you can manipulate your data in time domain. You can decimate it. For example, here is different pre-allowed decimation rates. Then you can resample it. For example, now it is 3 and 2 kilohertz sampling. We can to resample it, for example, to 3 kilohertz and apply, and a little bit to wait for. And if you're doing it here, the processed event will be added like a second event here, we can see. And for example, we can compare the results directly in the time domain using this tool. And as you can see, now is nothing changed actually, because the difference in sampling rates is not so big. So let's remove this one event. Using context menu, you can to remove or export time series, for example, in the event. Then you can use a notch filter, for example, for some power line. You can use your own custom FIR filter. And if you have some CSVM data, you can use CSVM filter, which I describe a little bit later. And I think it's all about time domain pre-processing. Then let's go to the settings. What you can do here. Of course, if you want to pre-process your data during the processing, you can add some preprocessors. For example, decimator, selecting some rate, or some notch filter, and here you can, for example, add all some subharmonics, which sometimes is useful, and some custom filter. It will be added here as a list and will be applied during the processing. Then you can select type of processing, MT, CSM, RMT, and some specific type of processing. You can calculate your calibrations, but I think today I will not tell about it. Then changing the window of your Fourier transform. Using the arrows, you can change the integer power of 2, but it's not mandatory. You can, for example, use arbitrary length. It's useful, for example, for Phoenix data where your segments are not so long, and maybe to avoid the missing of data, you have to make something like 2,400 or 1,200 samples per one window. Specifying the overlapping of windows in percentage using some taper, and you can, for example, use slip and taper. You can rotate your spectra for arbitrary angle, apply or don't apply your calibrations. And before this, you, of course, can go to the calibration tab and go to the tools and check, do you have calibrations or not? If it is empty here, the EMP cannot find the calibrations. And maybe you can zoom it one more time and check if your calibrations are okay. This is about calibrations. Then you can switch on or switch off time domain pre-awakening, as we discussed here, for example. estimate quality. Yes, this is pre-weighting in time domain. And for example, if you have mostly contaminated data, and of course, this is absolutely data adaptive algorithm, and if your data are mostly contaminated, your good data will be downweighted. In this case, you can use only in this button to invert your weights, to use 1 minus estimated weight to use the not contaminated data. And also you can switch or switch off the pre-whitening. It's very simple. First difference pre-whitening. Switch on, switch off the Robustical estimations. And here is something interesting. Here you can select the type of your reference channels. It works same in single station, and for a remote reference ports, you can use it's a channel which you use as a complex conjugate in your transfer function estimations. You can use magnetic type of channels, you can use electric type of channels, or you can use some specific estimator which guarantees you that the estimated impedance and admittance are mutually conjugated tensors, and multiplication of z and y will give you a unit matrix. Sometimes it's also good. Then you can switch on decimation or switch off, and for MT it's also possible to switch on or switch off smoothing of the spectrum. Here you can check there or change your frequency step for transfer function estimations. Usually it's a logarithmical, but you can use linear, and the EMP will compute transfer functions for each point of your spectral frequencies. Then, for example, for MT, you have some preselecting criteria. Here is a lot of them. Let's a little bit extend. Simple coherency with some descriptions here. Coherency of inputs, coherency of outputs, and many things, including some orthogonality and polarizations. You can switch them on or switch them off, set some minimum maximum thresholds, and manipulate of including or excluding. For example, if your including button is switched off, this particular band will be excluded, not included into processing. And yes, for MT, I think that's it. About other type of data, we will discuss a little bit later. Give me please 1 second. Yes, the most important thing here is a button to create the processor. You can add several processes here. For example, we can just check what will happen if we use different types of reference channels here. It is a name, just a name, to don't be confused. Then, of course, switch over the calibrations, and yes, make the different type of reference channels here. Then let's go to the transfer functions and compute. This is a one processor. This is another one processor. And this is a final one. Let's go here to the tools area. First of all, of course, if you want to use seconds in the x-axis, you can select it, or square of seconds, kilohertz, or hertz. Then here you can manipulate the visibility of different transfer functions. For example, for phase tensor also, but now it's not very important. For example, doing like this, you can compare your results from different processors. For example, here you can see the advantages in this band of using your HE type of processing. And going here, changing your settings you can see how the settings affects to your results. Also, you can do same for spectra, for example, hiding some channels here, or looking at coherency, different types of coherency, for example, selecting different channels here, 2-channel coherency, or maybe 3-channel coherency. And in 3-channel coherency, it will be a partial coherency for a clean spectra. Then you can select, for example, cross magnitude or phase shift. I don't know, is it useful or not, but you can do that. And also you can manipulate the units of your, or normalization of your power spectra to look at power or to power density, manipulate over the units, root of spectra or not. This feature we will describe a little bit later. And I think that's it about spectra tools. Yes, this is all about spectra tools. And what about these lags? I'm sorry. It's different decimation levels, because we have some noisy data with very sharp noises. Of course, decimation here works not so well. That's why we have little gaps after filtering. Of course, in this case, I don't recommend to use decimation at all. But just for example, we are discussing this. And for example, here, if you selected one appropriate settings, you can, for example, press button, leave only this, and voila, it is applied. And that's yeah. One more tool is filter design. For example, you can make some your own filter with arbitrary stops or reference points. For example, here, let's say 1 kilohertz reference point. Here, 4 kilohertz, 40 or 400 hertz. And yes, and here's a gain. And this is your calculated response function of the filter. You can, for example, play with the order of your filter and save the filter as a, how to English, not the, yeah, response function, to use it during the processing. But my mind is not so useful in MT processing. So, but what is the useful? For example, in this particular situation, we have very spiky noises. That means, as I told, the filtration and decimation will work not so good. And for example, let's look at not decimated data, increase the windows to cover more frequency range, and look at response functions. So we can see that, of course, it's okay for this type of reference stations, reference channels. But for example, if usual magnetic type processing, we have a very contaminated data for Z, Y, X in the high frequencies. Of course, because of these spikes. For example, if you want to have the low frequencies in your processing result, you have to use the long window without decimation. But in this case, in this particular type of reference channels, you can't use it because you have to use short window to down weighting this realization with noise. In this particular case, you can, for example, add one more processor. Let's name it LF and HF. HF like this. And for example, use LF for 100 Hertz. And here you can use 100 Hz for a lower bound, but decrease your window length. And let's, yes, maybe increase a little bit here to go to the lowest frequencies. And let's look at the result. Now it's very much better because we discarded some data in the time domain. For example, if we hide it, we can look at the short windows down weighting these spikes quite precisionally. Then, for example, same for spectra, coherency is good. For example, let's look at another one, coherency here is also good. And we can see same here. But for example, here we have some gap between the different frequency ranges. Maybe the HE estimator will be better. Let's check. Yes, it's better. And that's how easy you can change your settings and immediately look at the results. So I think this all about this feature, and I want to discuss a little bit more about this function. All segments means all segments. If you're switching it on, no, firstly, I have to describe a little bit how EMP processes the data. If you have very long time series, it cannot process all of them in the memory in the same time because it split the time series to around 40, maybe 20 segments, process separately, and estimate some average result in the final. But if you use this feature, you can look at results for different segments and, for example, compare how they're stable, is your final estimation is reliable, and so on. And in this point, I'm going to another one example posted in the internet with very interesting data. First of all, of course, we are looking at time domain, and it looks not so easy, let's say. Then, and yes, here we see that it's only 5-second sampling period. It's very low frequency MT soundings. That's why we can to assume that our decimation can work correctly here. But for example, let's start without decimation, just increasing a little bit. Our window length, save this feature and save the decimation. And let's look at the results. Yes, this is our, for example, one coherency between EY and HX is very, very bad coherency, but for another pair is good. And we can see same thing in the transfer function plot. For example, this component is good, and this component looks like a trash. But let's look at a little bit details. Yes, I'm sorry, I have to describe. I set it too big time window, and it's not enough realizations to use segmented processing. To look at this feature, I have to reduce it a little bit and recompute. And yes, please switch off the decimation also. Here we can see all segments. And if I will extend it, we can see how many they are, and each of them for specific time band. But here you can see there, for example, this is the final estimation, and this is the cloud of your estimations for each segment. And somewhere here is apparently good result, but most of them are not. And for example, clicking here, we can to travel around the segments and to look where the data are crashing. Okay, and maybe to the end. Yes, somewhere from this situation, from this time, data are bad for second polarization. Somewhere in the 6,000 of hundredths of seconds. And of course, its very lots of segments are contaminated. That's why average response R looks like trash. It means we can go back to the time domain, reduce the time of the processing, for example, somewhere here, as we estimated right now, and just recompute. And yes, it work okay, but of course it's not no enough segments anymore for comparison. But of course our estimation is much better. And now maybe we can extend the length of the window to go to the lowest frequency, recompute it, and okay, it looks quite nice now. Also, we can look at these components. It looks also nice, and that's how it works. And it's a new feature I added just maybe yesterday or a couple of days ago, and it's very useful in some difficult situations. Then, what we will discuss then? Yes, if you're using a single station processing, it is only poor count of your transfer functions, but only the existing transfer functions in your file are here. And for example, you can switch to the impedance or to apparent resistivity, up to you. Then, if you finished your processing, you can save it. And here select the type of output file: processing schema to use to other stations, EDI, TXT transfer functions, binary type series, text time series, text power spectra, and so all stations as EDI. It's, for example, useful if you are reprocessing your data or correcting your data from EDI files and you want to save all of them immediately. So let's look at remote reference data. It's here. Let's go to the info tab. Where is my map? Sometimes it's okay. This is a map. Little bit move here or just hide it. Here you can see two different stations. One very long and one a little bit short. Of course, longer is the reference stations is here, and this short is for survey area. Yes, also we can extend it here, just to look at. And then, okay, time series is good. Nothing to talk about here. But now, in the event list, you can see error sign and some stations which can be used as a remote reference. If it is several stations with overlapping time of measuring, you will see here the combo box where you can select your necessary reference stations. And for example, test the results with processing with different reference stations. But if you see this sign, it not means that your processing will be a remote reference. First of all, you have to switch it on using use channels of reference stations. And for example, now it is allowed the one more feature, your cross-weighting. If you selecting the cross-weighting, it means that first estimation will be for your particular station and the reference station as a reference, of course, and then they will be split, and the reference station will be assumed as a usual station and usual station as a reference to suppress noises in the other channels. And then, okay, let's, for example, compare results with and without remote reference processing. To make it faster, let's switch over the decimation, switch over this type of processing, and this will be single station, and this will be a remote reference one without cross-weighting. For example, go to the transfer function. This one, this is the second one. Oh, I forgot to switch over decimation. No, I didn't. Okay. First of all, I want to say that now you can look at horizontal magnetic tensor in green, and actually you can use the color picker here. You can look at horizontal telluric tensor as well, and of course phase tensor. But now I think we can switch them off. It's not so important. And compare your results. It's apparently that in deadband, AMT deadband, the data are downshifted because of bias. And remote reference, of course, help to somehow fix it. I think it's nothing more interesting about the remote reference processing. But one detail, for CSEM processing, you can use in the same manner the time series with your current, to use it as a reference station or reference channel to compute transfer functions relatively to the current. Then we have a nice button, compute all. When you did all preparations and press this button, apply processing schema to all similar events to the all similar stations. Then you can press to compute all, select the necessary file format for outputs, select your directory for outputs, and continue and just put your legs on the table. And I have nice figure. Yeah, like this. Sit like this and look at your processing, conveyor processing all of data. But a little detail about this type of different extensions. I don't recommend here to use all of these types of processing, because using EDI, you can save the results, then open them here to correct it, to change it, to remove some outliers, and to save them to any other formats for inversion. With this type of files, you cannot. You can do only the inversion. But EDI is a very useful format, at least in EMP. And now I think, yes, we are finished with the empty type of processing. And now let's go to the, for example, RMT type processing. This is our file with RMT measurements. Here you can see two events. One event from 10 kilohertz to 100 kilohertz, and from 100 to the 1 megahertz. Of course, data looks good, and here you have another set of tools. For example, you can set off the different type of preselectors, like a signal noise ratio, bearing or azimuth deviation, coherency, and ellipticity. And here you can use button tensor processing. And for tensor processing, I'm referring to this paper by Bastani and Peterson. So if you're interested in details, please read this paper. I just want to say that in EMP it's failed, but if you want to use, let's say, usual processing, narrow band processing, switch it off. And first of all, let's look at results here. Let's increase a little bit window of FFT, of course, to use narrowband processing, switch on the calibrations, and yes, just coherency threshold right now. Also for this one, and go to the spectrum. Spectrum looks okay. We can see the VLF stations here, some transmitters from Moscow and other spikes. But more interesting, of course, is the transfer functions. For example, let's hide this. And yes, it looks like a curve, definitely. Not so bad, but a lot of garbage are here. To eliminate the garbage, you can switch any type of preselector, but I will do it for all of them now. And for example, compute one more time, and look that data are vanished. Now it's much better. And for example, is one more useful button here for if your phase are in different quadrants, as have to be, of course, but it's not so useful to compare. You can click compact phase to move it to the first quadrant. And of course, here you can see that this works not so bad. Then let's discuss a little bit, not discuss, just illustrate how works the tensor processing. And if you're switching on the tensor processing, of course, usual processing is only scalar because radio transmitters have polarized signals only. But tensor processing is a wideband processing for all frequency range in same time. And in this case, you can switch on the processing for regular mesh, of course, by frequency, because in the raw data, they are very scattered because of original transmitters. But clicking here, you can make the estimations for a regular mesh, like in MT. And for example, let's compare them results. First and second. Okay. Now they look like some empty response. It's absolutely up to you, use it or don't use it, because I want to worry you that if you have some outliers in transfer functions, this feature will work not so good and you have to be accurate. And one more interesting idea about this. Here you can see the list of frequency stuff. Of course, for MT is useless, but for RMT and CSM processing is very useful. For example, you want to look at your automatically selected frequencies. You can make new list, maybe call it auto, and add here switch frequencies. And here they are. One for these polarizations, another for these polarizations. You can change here to make it auto selecting or tensor processing. But of course, you can look how it's selecting. For example, here is coherence only spike. You can remove some. And for example, if you have some CSM data, you can, oops, not so. Let's remove this. Press here. And for example, for rectangular waveform of your transmitter signal, you can use main frequency and subharmonics. Here, for example, let's say 5 kilohertz, and like this, maybe edit 19 subharmonics for tensor processing at odd only, and yes, here they are. 1, 2, 3, 4, 5, 6. Of course, it will be better to make it here. Like this. Yes. And you can, for example, switch them on, switch them off, and look at, and use them here. If, for example, you are working with control source data, for example, CS-AMT or CS-RMT with impedance estimation, you can use here some list. for particular frequencies because it's, I think, not so good. Don't use this feature to process control source data. And your estimations will be for particular selected frequencies only. So this is about RMT processing. And of course, for RMT processing is very useful conveyor processing because in RMT it's very lots of stations. Then let me please go to the CSEM example. Go to the time series, and here you can see, of course, that it is control source signal definitely. And one more features in time domain. For example, dragging the pressed left side button by the mouse, you can send a ruler and, for example, estimate time lag or frequency here and count of samples per your period of your transmit. And I just know that here is, let's say, this frequency. We will add it here and like this. No. Okay. Only odd harmonics. Here they are. Little extend your processing downward to 1 kHz, and same for processing schema. And let's compute to look at. Oops. If you see their picture like this, you forgot to tune your window of Fourier transform. Of course, it has to be bigger to make the narrow band processing. And here you can see that it's good. We matched the signals quite well. And now the processing result looks like this because we used only automatically selecting of transmitters. But now we can use only specified list. It marked here that we are use a list, recompute, and look only the transmitter signal transfer functions. Yes, here we have only scalar one. This one we can to manipulate only this one transfer functions. So what else? I think that's all about processing itself. And now let me please go to the EDI data manipulation. Of course, here is a lot of EDIs without coordinates. Let's check it. Sorry, let's correct it. Use coordinates here, close, and maybe update the data coordinate system. Put it somewhere here to correct azimuth, just to make the lines collinear to the x-axis, and leave it. Now, this is a response. If you have spectra, they will be here, but now it's not. You have only response function. And first of all, you can switch on or switch off the single station processing results. You can switch on, switch off the remote reference processing results, E-reference processors, H-reference processors, switch off the error bars, look at magnitude phase, or look at real imaginary parts. All segments, of course, it will not work here. And one interesting and maybe useful feature here. Now you can see that ZXY and ZYX phase are incorrect quadrants. And you can check it using splines and dispersion relations. Let's switch off the tipper. For example, here it corresponds not so bad. And most important, you can use this feature to check the correctness on your quadrant of the phase. And for example, if it is not correct, you can press button it's here correct phase, shift it for example for one particular angle or make autocorrection, and autocorrection works based on dissipation relations values. All your phase curve will move to one appropriate quadrant automatically, and it can be done for all stations. Sometimes it's quite useful. Of course, if you have transfer functions and tensor transfer functions, you can to change azimuth or just rotate your response. And if you want, you can look at polar diagrams here, and clicking on the chart, you can select the necessary frequency to look at your polar diagrams. It also works in processing framework, not only for EDI data. And now we can go back to our EDI files, and what else? What else? Now we can do, for example, look at data, of course. Let's, for a moment, hide the data coordinate system. Zoom a little bit, maybe switch on this map, more nice, and data on map. Yes, let's switch on data on map. Now we have some tools. This is a frequency slice. Frequency slice for some selected particular frequency. Of course, here is interpolation step in pixels. We can reduce it or increase. And switch radius for inverse distance interpolation, or use just linear interpolation, for example, if you want. But I prefer this one. And for example, increasing the window, and it becomes quite nice. Of course, we have a geographical north here. Then, if you want, you can tune the opacity of the map, or maybe add the polar diagrams. But one moment, if you're adding the polar diagrams and you can see nothing, it means that your scale for polar diagrams is too small because it's not tuned automatically. You have to go to the plot settings. For example, here you can tune your chart settings or whatever. Then here is polar diagram settings, and let's increase our scale. Okay, now it's 1000 times bigger, and now it looks better. Let's hide our stations, and for example, make it white, and make it white also. And now maybe we can zoom. We can go through the frequencies to look how it changes frequency by frequency, or hide this. Also, we can use what it is, induction errors, for example. Also, we can tune the scale of induction errors. Yes, for example, 20, now 50. And 50 for imaginary part. Maybe hide this, look at this. And also we can look at phase tensor. Phase tensor, of course, have to be tuned as well. Boom, boom. Okay. It's not colored because I didn't realize now how to combine coloring of the map and the phase tensors. And of course, you can go through the frequencies, look at your results, you look at your data, analyze it a little bit. And then, for example, let's switch on our stations. For example, you analyze everything, and now you can select some stations, for example, for this line, using the mouse and using the wheel to tune the radius of this edge. And now when you select it, you can see it here. You can save results. Save. And now you can save for selected only data, for example. Okay, frequency slice will be saved for all data, but the data for inversion will be saved for selected stations only. For zone, for Rebel, for Mackie, for magnetotelluric, for MOD-EM. Of course, for MOD-EM we can select all of them. And some polar diagrams for Google Earth, for UTM, like a text file, and interpolated slice of frequency. For the particular transfer functions you selected here, it can be impedance, this impedance, that impedance, apparent resistivity, not apparent resistivity, maybe magnitude, phase, real part, imaginary part, whatever you want. So this about data analysis and corrections. And yes, of course, one maybe the most useful feature for correction of the data, if you have outliers like this, you can use this tool, switch it on, and just trash away your outliers. It works for visible data only. If your data not visible, it will not damage it. And then switch it off. And of course, if you have some reference stations, some reference responses, and you suspect that you have a static shift, for example, you can use selecting like this, make it crosses, then go to the moving and move your response along the y-axis. Of course, it's not well done yet, but just preparation, but you can do it. And for example, now compare them. Okay, let's deselect it by the right hand side button. And then we can discuss a little how to work around your 3D model in the EMP. In EMP, it's allowed to construct the model for a finite difference MOD-EM code. Let's maybe hide all data from here. And what about data coordinate system? Show it. Yes, is correct. Show it. Here we have a button, a model. We can, for example, load it from the file, but right now we can say no. And do you want to create a model? Yes, I want to create the model. And now you can see the top view of the mesh. And here you can, for example, tune your steps of your cells, count of them like this, and watch. Does it cover the area of interest or not? For example, some changing in the extension nodes, add them or don't, make it regular or square, make it more, for example, like this, and some depth from 1 meter, 1 extension factor, and for example, 40 cells. This feature too is how deep the linear step will be saved. For example, if you have topography, if you load it into your EMP model, you maybe will want to accurately digitize the topography. Because of that, for example, you can make the same linear step equals, for example, in this case, 1 meter, down to first 10 meters or down to first 20 meters of the model to accurately digitize the topography. But now it's not so important, just apply a couple of seconds, and yes, we can see the model. Of course, we can play with opacity of the model to compare, for example, with features of the topography and the topology. And then we can look at section here, zoom it. Then, for example, we can change the direction of the slice. It indicated by this black line along the X, along the Y. Maybe you want to change the level of your section. I mean, depth section visible in the map. It indicated here in your cross section. And one maybe useful feature is trimming of your model using these tools. If you want to look at cells on the area of interests only, it can be useful. And then the most useful feature of the EMP model builder is the surfaces. Surfaces is some abstracts which used to the building of your three-dimensional model. You can load here, for example, topography surface, which looks like a simple text file, latitude, longitude, and altitude columns. Open. Now you can use following, of course, model notation to where to fill the model relatively to this surface, above the surface or below the surface. Which value you want to fill the model by? For example, this will be air. Of course, it will be filled above the surface by high resistivity. To use specify some code for this area, 0 for air, but not 0 for the ground. And here you can select the original coordinate system of your surface vertices. For example, in my case, it's VGS84, but it can be UTM, and you have to specify the zone of the UTM data. Or it can be data coordinate system accordingly to this your particular data coordinate system. For example, here is 0, here is plus X, here is plus Y. But in my case, it's VGS. Just continue, and here you can see that 1,200 and so on vertices are loaded. This indicates that model will be filled upward relatively to the surface, and you can combine many of surfaces like a pie here. Add one more. For example, 10 surfaces. Then set your background resistivity and rebuild the model. Rebuild the model uses the linear interpolation of your specified values in the surface. And now, for example, you can see that we have a topography. But interesting thing, yes, of course, here in the top view, we can look at this green areas is the model, but here we can see the model because it is the air, apparently. It's transparent. If it is a 0 code, it is transparent. And going downward, we can look how the topography is changing here. Is it okay or not? Maybe we have to change something. And for model, very important things. Now you can see that go to this direction, for example, to make it more obvious. Yes. And one more time. Oops, sorry, not here. Where are our? Yes. Here are stations somewhere in the ground, in the 0 altitude. But we have a topography. When we are exporting our data, we have to fix it to put the stations on the surface of our model between air and the Earth. And now we have this button, correct altitudes of the stations. But before doing this, let's select all of data, because this feature is work only for selected data. And yes, let's press. EMP will ask you where you want to situate your stations. On the topography. Yes, in this case, it's on the topography. Or on the seabed, if you have another code corresponding to the water body, of course, I'm referring you to the manual of the modem in this case. You can to specify your stations on the seabed, or if you have some hybrid measurements, you can use both of them. And some altitude, maybe 10 centimeters deeper than surface, and continue. Yeah, and so is it works or not? Maybe let's press 0. No, it apparently doesn't work. I have to fix it somehow. Yes, I'm sorry. I'm sorry, but yes, I have to, of course, situate it on the surface, but apparently it's related to the another direction of the y-axis. Okay, now it's nothing important. I will fix it. And of course, when you build it your station, build it your model, you can save it. For example, for modem, or some section for modem in 2-dimensional. For example, for VTK, but I think it's not work quite well, and some slices for the visualization. So I think it's all features of EMP I wanted to tell you about. One more feature is adding the transmitters here, just to simplify the visualization. You can specify the color and so on, hide it or don't. So I think now I have to stop, and maybe we can go to the discussion.
Yes, well, thank you very much. I have to say I'm thoroughly impressed. I've heard, yes, sort of EMP, I think maybe it's on even on MTNet, but I had no idea how far along or how advanced it is. And yeah, I have to say, I think these interactive elements that you've put in there are really something that help us. Yes, I think you said it. Yes, you were sort of not very happy with the academic software where it's usually, run some MATLAB script or some command line interface, and if you want to do anything, it's like change code. Yes, I think a lot of us work this way, but I think there's also a lot of value in having this possibility, for example, to directly compare processing output, like what you showed, yes, with these different processing schemes, and immediately be able to say, to click, okay, I want to see this one versus that one, and immediately get an idea what is better. Maybe a first question while people are typing. So what is the processing back end that you're using? I mean, it seems to be some sort of robust remote referencing, but is there a specific paper that you are implementing for your?
Yes, I'm referring to many of papers in the user manual, but it's not, I not just borrowed a single code into the EMP. It's my code, but of course it's based on BIRP, it's based on Gary Egbert's code, Alan Jones' code, many codes that I saw, and I took some ideas from that, but in general it's my code.
Okay, but there are sort of references in the paper, so if people really want to sort of understand.
References are in the manual, yes.
Okay. Okay, we have a first question from Vikas Paranval. Very good work indeed. I saw you have a button for aero as well. Can your software deal with airborne data?
Yes, I have this button, but it's right now for me only. It's not a public version yet because it's just some for my own purposes. No, it's not finished for broad auditory right now.
Okay. But maybe sometime in the future.
Of course, maybe yes.
Yeah.
Sometimes.
Okay, while we are still waiting, another question I have about your model export, because what you showed was actually a very interesting example, yes, where your data are in some sort of rotated coordinate system, and you created a model grid that was then also rotated. Now, as far as I know, ModEM cannot, if you want to directly deal with it, that you just specify some rotation angle. So do you then have a function that makes everything consistent for ModEM, rotates the data, or how do you do that then?
Yes, of course, all rotating is in the backward of the EMP. But if you use straight data coordinate system, it will be not rotated. But it depends. Is your data are orientated to the true north or some angle? If to some angle, they will be rotated to your data coordinate system. Yes. It's
Okay.
same for ModEM and it's same for Mali to the EM. Yes. All rotation is in the black box.
Okay. Yeah. Because that's also like an eternal, not struggle, but sort of nuisance, yes, that you always have to sort of double and triple check that your data is in the
Of course, yes.
right coordinate system. Okay. Xenia Nipena, very impressive. Do you have also Visa arrows tools, or so your induction arrows, are they Visa convention or Parkinson? Can you switch?
I don't remember exactly. I think it's only one convention described by Vozov in the EDI file documentation. I don't remember which one it is.
So you just take whatever values are in the EDI file?
Yes. No. It's calculated from tipper. It's calculated directly from tipper.
Then you make the arrows. I think then it's typically Visa, because I think Parkinson is the reverse. You put a -1 so that they point to the conductor.
I think it have to point it to the conductor.
You just point to the conductor. Okay, so that would be Parkinson.
Maybe, I don't remember.
No. Well, make a synthetic model.
Yeah, maybe in manual described. Maybe in
Yeah.
manual it is. Yes.
Yeah. Okay, people are still typing. I can ask many questions. So one feature you also had with the processing, yes, you can load Phoenix time series, and then you were talking about calibration, and I saw that you show the sort of the frequency dependent calibration. So do you directly read in the Phoenix files, or is there some conversion that needs to be done? Because that's also like a point that I've spent.
For Phoenix is some specific story, because original binary structure is proprietary, it's not opened, and EMP works with the some ASCII variant of Phoenix calibrations only. Yes.
Okay. Yeah, so you have to run it through this, whatever it's called, cal something tool that spits it out, and but then you can read those files directly. Yes. Yeah. Okay, so that's the usual.
For Metronics, it works both for ASCII and for XML calibrations.
Okay.
If you have XML, it will take it. If you have no, it will try to switch for ASCII.
Okay.
Secrets. Many secrets in the industry.
Oh yes, yeah. But I mean, in that sense, I think also your tool is a great contribution, because I mean, I would say this is nearly like WingLink, or what's the other one, GeoTools. Yes, the big super expensive processing or sort of analysis suites. I think you don't really have to hide from those, or there's not so much functionality missing. I think they might have some 2D inversion or something in there, but otherwise that's already quite close. It's unusually quiet, so I'll just keep talking. I mean, maybe one thing I can is more like a comment, because I've sort of put out code as open source, and I think it's never ready. Yes, you're never ready to show it to the world. my encouragement, I mean, I sincerely hope, I certainly will have a look at this in more detail, that people will take up the code, because as you said, then when other people start to use your programs, they also find bugs and everything becomes a lot better relatively quickly, because people, you know, see or sort of do things a different way than from you. And of course, having it open source helps in that respect. But of course, there are many factors to decide that.
Yes, many factors. Maybe one more factor is the language I use is C#, and as I know, nobody in geoscience uses it.
Yeah, of course, and that's all, of course, always a thing. And I mean, by now, you seem to also use it to, I think, great advantage with all this sort of interactivity. Yes, that of course it's not a trivial thing to then do it differently. Okay, we have another question. Meran Garibi, thank you for an interesting talk. Are the EDI data in spectral or empty response format? When you edit the data, so rotation, static shift, are they applied on all matrix elements in the spectral matrix?
So EMP reads both transfer functions and spectral responses from EDI, and it can take both. If the only spectral data in the file, it will compute all possible combinations of transfer functions inside the EMP. Then, if you make some manipulation with data, it doesn't affect spectra at all, only transfer functions, and only for visible transfer functions. For example, as I demonstrated, you can leave the visible only one curve, which is shifted or distorted on something else, move it, clean it, then switch another one, do another manipulation with it, and save to the file.
Okay. Yeah, although, I mean, I think the shifting tool is useful, but also dangerous.
Yeah. It's not finished really.
Well, at least you don't have, like, I think Wingling, I don't know if it still has it. There you could even shift individual data points. And I always thought that's going a bit too far. Yes, when you can shift your one sort of strange data point to where you want it to be.
For example, for narrow band processing, if you have only one frequency outlier, it used to don't delete it, but just shift to your curve, because you know exactly where it has to be, but it's up to user.
Yeah, I think, you know, well, that's a separate discussion, yes, because you can, there's a gradient there from proper, if you want, so data curation to data manipulation that is sometimes a bit difficult to navigate. Well, it seems that questions have been answered. I mean, as I said, I definitely will take a much closer look at this program, because I think there are a lot of good uses for that. I mean, certainly, well, nearly whatever you do in EM, and yeah, hopefully that will also help you to work on it further. Yes, getting feedback from the community, and if it spreads a bit, gets used a bit more, you know, help you otherwise. So thanks again for presenting and showing us this, and for everybody else, and well, also for you, don't remember, next week we have Tibor Astik talking about joint inversion, and well, actually another piece of software, I suppose, SIMPAC, for modeling and inversion. So everybody have a good day, and thanks for tuning in.
Thank you.
Bye.
Yeah, see you.